from Firestone Complete Auto Care. What is a car alternator and how does it work? What is a car alternator? Your alternator is one of three main parts that make up your vehicle's electric charging system. The battery and voltage regulator are the other two. It looks like a small cylindrical generator, and you can typically find it bolted to the engine. What does an alternator do? The battery is essential for starting your vehicle when it's off, but what is the purpose of an alternator in the car? It supplies electricity to the battery and electrical system to keep your car alive when the engine is running. As you drive around or idle, the alternator powers key components like headlights, dashboard lights, power windows, radio, air conditioning, and other electrical features. Its role in recharging your car battery while driving is equally important, ensuring your battery is always ready for the next start. How does a car alternator work? Your car's alternator generates electricity by converting mechanical energy from the engine into electrical energy. When the engine runs, it spins a belt connected to the alternator, which turns a rotor inside. This motor creates alternating current, AC, which is converted into direct current, DC, to power your car's electrical systems. Alternator components. Several parts work together to help your alternator generate electricity. Here's a closer look at each of them. Pulley. A pulley on the exterior of your alternator is turned by a drive or serpentine belt connected to the engine's crankshaft. This movement powers the alternator by providing mechanical energy that it can convert into electricity. Rotor. The rotor is a cylindrical part inside your alternator. It has winding and magnetic poles arranged in a triangular pattern, alternating between north and south. As it spins, the rotor becomes an electromagnet. Stator. The stator encases the spinning rotor and contains three copper wire windings. As the rotor spins, it generates alternating current, AC, in these windings. Voltage regulator. The voltage regulator controls the rotor's electrical input, preventing too much voltage output from the stator from damaging your car's battery and other electronics. It adjusts the electricity powering the rotor to keep the desired alternator output. Rectifier. Car batteries work with a direct current, DC, charge, but the stator creates an alternating current, AC charge. The rectifier converts the AC charge into a DC charge, so the power is compatible with your battery. How long does an alternator last? Alternators can typically last the lifetime of your vehicle, providing a reliable power source for your car's electrical system. However, general wear and tear, heat damage, overuse, exposure to water, faulty parts, or frayed wires can put your alternator out of commission before your car heads to the scrapyard. Be on the lookout for signs of a bad alternator. That could mean a visit to Firestone Complete Auto Care is in your future. How to help extend the life of your alternator. Like any part of your vehicle, proper maintenance and good habits can help maximize your alternator's lifespan and prevent costly breakdowns. Here's how you can help keep your alternator in top shape. Reduce electrical strain. running multiple electrical accessories at once, especially while idling, puts unnecessary stress on your alternator. To ease the load, turn off systems like heated seats when they're not needed. Inspect the drive belt regularly. A worn, loose, or damaged belt can make your alternator work harder than necessary, leading to early failure. Have the belt's condition and tension checked regularly to ensure proper alignment and function. Keep connections tight and clean. Corroded battery terminals or loose alternator connections can disrupt charging, forcing the alternator to work extra hard. Inspect and clean connections regularly to ensure a strong electrical flow. Maintain your battery. Your battery and alternator work together. A weak or failing battery makes your alternator work overtime to compensate. Test your battery regularly and replace it as needed. Warning signs of a bad alternator. If your alternator fails, your car won't start, or might run just for a few minutes. However, the signs of a failing alternator are often mistaken for problems with the battery or other car parts that display similar symptoms. In other words, if you're experiencing only one of the issues below, you could have a faulty alternator. Dim or overly bright lights, dead battery, slow or malfunctioning accessories, trouble starting or frequent stalling, growling or whining noises, smelling burning rubber or wires, illuminated battery warning light on the dash. While these warning signs can be helpful indicators, they can also point to potential issues with your vehicle's overall electrical system. Bring your car to your local Firestone Complete Auto Care to have your electrical system inspected so we can get to the root of the issue. Stay powered, drive confidently. Is your car struggling to start or keep its battery charged? A faulty alternator could be to blame. If you notice any problems with your car's battery or electrical components, turn to the trusted pros at your nearest Firestone Complete Auto Care. Our skilled technicians provide thorough diagnostics and expert alternator services to identify and fix the problem, whether it's the alternator, battery, or something else. From Continental Battery Systems. How does a car battery work? The lead-acid battery that powers most modern vehicles has been around for 150 years. The basic technology and construction have changed very little since French physicist Gaston Planté invented it in 1859. Today's modern car batteries power the starter motor, car radio, and everything in between. Without it, your car is nothing more than a non-movable hunk of plastic and metal. If you ever wondered how a car battery works, read on to learn more about how it helps keep your car running smoothly and safely. How does a car battery work? A car battery uses lead-acid technology to turn chemical energy into electricity. It accomplishes this through the usage of cells, which contain and store the energy until needed. Most standard car batteries contain 6 cells that are situated in a row inside the plastic casing. Each cell contains a lead dioxide plate and a lead plate. Together they create 2 volts for each cell, which is why it's often referred to as a 12-volt battery. The rows of cells are submerged in sulfuric acid, which triggers a chemical reaction between the lead dioxide and lead plates, and this creates lead sulfate and ions. As the ions move freely around the lead plates, another chemical reaction occurs, which produces hydrogen and lead sulfate. The movement of ions generates electricity that moves to either the positive or negative terminal of the battery. The two wires that connect to your car battery then disperse the electricity to the starter motor and other vital electrical systems. How does the car battery recharge? A device called an alternator recharges the battery as your car drives. It generates an electrical current through an alternator belt that's attached to the engine, which turns physical energy into electricity. As the belt turns the alternator, it creates electricity, which is then used to power the electrical systems of the car. Some of the energy that it creates is sent back to replenish the battery. The voltage regulator is a device that helps keep the flow of electricity to optimal levels and prevents the battery from overcharging. What are the different types of car batteries? Most cars on the road today have a lead-acid battery. This is the most affordable and common type on the market. The technology has been around for 150 years and has proven itself to be extremely reliable. Some cars, such as electric cars, use lithium-ion batteries, which have a different chemistry and a very high performance level. And capacity. Starting batteries. These battery types are all about cranking power and are most common in automotive and commercial fleet applications. Starting batteries usually feature thinner but more numerous plates per cell than a deep cycle battery, giving them more surface area for more initial starting power. Deep cycle batteries. These type of batteries are most often found on golf carts and boats as they offer sustained power over an extended period of time. These batteries generally have a deeper reserve capacity that provides longer run times for many electrical vehicles or extra accessories on a vehicle. Deep cycle batteries almost often have thicker plates, which results in fewer plates per cell, but more reserve capacity than a typical starting battery. Wet cell and dry cell, AGM batteries. When it comes to lead-acid car batteries, buyers have the option of choosing either a dry or wet cell battery. While the basic operation is the same, the difference is that this dry cell battery have a glass mat separator, which absorbs and suspends the electrolyte, while a wet cell submerges the plate in an electrolyte solution. The dry cell battery is typically sealed and non-spillable. A dry cell battery allows you to mount the battery in more places, such as the trunk, and more configurations, such as on its side. A wet cell battery could potentially spill the electrolyte if this occurs. This greatly limits the placement and positioning of a wet cell battery. It's safer to keep them upright under the hood of the car. What is cranking power? The engine of your car requires physical cranking power to start. The exact amount is based upon several variables, such as engine size, temperatures, and engine type. This power is called cold cranking amps, CCA, and is a measurement that determines the overall cranking power of the battery. The formula for CCA is the number of amps that a 12-volt battery can produce at 0 degrees Fahrenheit for 30 seconds, while simultaneously keeping a 7.2 voltage. The higher the CCA rating of the battery, the better ability it has to crank the motor. This is important if you live and work in a colder climate. Generally speaking, the colder it is outside, the harder a battery has to work to deliver the power needed to crank the engine. from Kia.com. What are car axles? A car axle is a central steel rod that bridges a pair of wheels. The primary role of axles is to get torque from the transmission and transfer it to the wheels. What are axles in a car? Axles are a crucial car component, but a part that many of us overlook. An axle is a rod or shaft that connects a pair of wheels to propel them and retain the position of the wheels to another one. In a car, the engine applies the force to the axle, which rotates the wheels and moves the vehicle forward. In other words, axles deliver the driving power from the engine to the wheels. As the axle spins, the wheels turn around, helping drive your car. Why is the axle's strength important? Aside from transferring the engine power to the wheels, the axles hold the weight of your car, as well as its passengers and cargo. They absorb the shocks coming from the rough streets. Thus, axles are usually made of robust materials that can better resist abrasion, fracture, deformation, and compression. The strength and stiffness of axles are found to be one of the most crucial factors for a car to achieve and maintain high performance as well. Sturdy front and rear axles can steadily transmit the powerful force from the engine to the road while offering you a remarkable amount of control, no matter what driving conditions you encounter. Different types of axle. Typically, a car has two basic types of axles. One is called the dead axle, that is present in a car to put up with the weight and does not rotate with the wheels. The other one is the live axle, that is connected to the wheels and propels them. A constant velocity, CV, joint connects the wheel and a live axle, allowing the axle to transfer power to the wheels smoothly. In addition to dividing car axles into a live or dead, they can also fall into other categories, such as a front axle, rear axle, or stub axle. Front axle. As its name implies, front axles are located at the front of your car. The front axle's purpose is to support the steering and process the shock generated by the bumpy surface of the road. Front axles may either be live or dead. Live front axles can perform the job of rotating the wheels as explained above. Rear axles, as you may have guessed, are located at the back of your vehicle. Most rear axles are live, meaning they are responsible for transmitting power to the driving wheels. A drive shaft is connected to your engine and turns the rear axle, thus rotating the car's wheels. Stub axle. A stub axle is found in cars with rear wheel drive and is attached to either end of the front axle with kingpins. Stub axle can be split into 4 types depending on the stub axle's arrangement and its subcomponents. Elliott. This type is attached to the front axle by using a yoke, kingpin, and cotter. Reverse Elliott. This stub axle has the reversed arrangement of an Elliott stub axle. Lamoine. In a Lamoine stub axle, an L-shaped spindle and kingpin are used instead of a yoke. Lamoine reversed. It has the reversed arrangement of a Lamoine stub axle. From the Universal Technical Institute. How do car braking systems work? key points. The braking system is the most important safety system in a vehicle and helps bring the vehicle to a complete stop. There are two primary types of braking systems in passenger vehicles: disc brakes and drum brakes. Drum brakes were the first type of braking system introduced and used hydraulic pressure to slow down the wheels. Disc brakes are the standard for most vehicles and use brake calipers and steel rotor discs to create friction and slow down the wheels. Signs of worn brake parts include vibrations in the steering wheel, having to press the brake pedal down hard, loud noises, the car pulling to one side, and the brake light on the dashboard coming on. There is no safety system on a vehicle more important than the braking system. This system helps slow down the rotation of the wheels when the brake pedal is depressed, ensuring a vehicle comes to a complete stop. There is a lot going on within a braking system during this process. Keep reading to learn more about the different types of car brakes, the parts they include, and how they work. Types of braking systems. Braking systems in passenger vehicles use two primary types of brakes: disc brakes and drum brakes. While they both bring a vehicle to a stop, they differ in design and operation. Disc wheel brakes. Disc brakes are the only type used in the front of vehicles, but may be found on all four wheels. All passenger vehicles made and sold in the United States will have disc brakes on the front and possibly the rear as well, while drum brakes will only be found on the rear of US autos. Drum brakes. Drum brake systems were the first in-tire systems introduced, released in 1900 and patented in 1902 by engineer Louis Renault. While the first designs were completely mechanical and used levers to operate, by the mid-1930s they were applied using hydraulic pressure. How do drum brakes work? This system consists of a master cylinder that sends pressurized brake fluid to the wheel cylinder, located inside the brake drum. This pressure causes the pistons in the cylinder to expand and press the brake shoes against the inner surface of the brake drum, which creates friction to help slow the spinning of the wheels. Disc brakes. While disc brakes were patented the same year as drum brakes, it took almost a half a century for the designs to become practical and cost-effective for use in automobiles. Their superior performance over drum brakes were first realized by Jaguar in 1953, when they used them on a race car that triumphed over other cars using drum brakes. Later that same year, a production car was sold with all disc brakes. Since then, they've been considered the standard for most vehicles. This system consists of a master cylinder that sends pressurized brake fluid to the brake caliper, causing its pistons to press against a steel rotor disc, creating friction to slow the spinning of the wheels. Drum versus disc brakes. While drum brakes have their place, they also have disadvantages when compared with the disc type. Manufacturers have come to prefer the disc braking system because of its many advantages, which include cleaning. Unlike drum brakes, which need periodic cleaning due to brake dust collecting on the shoes, disc brakes are self-cleaning. This is thanks to the brake pads wiping against the rotors when they're engaged, effectively cleaning themselves. Consistent performance. Disc brakes are better at managing heat than drum brakes. Drum brakes are likely to get hot with repeated use and experience brake fade, which can result in a vehicle needing greater distance to stop safely. More stopping power. Advancements in technology have made disc brakes more durable and better equipped to bring a car to a stop faster. Handling during wet conditions. Disc brakes are open to the air, meaning water can come off easily. This makes them better at performing during wet conditions, as drum brakes have the tendency to trap water. Parts of the braking system. Every part of the brakes of a car plays a key role in the stopping process. While disc and drum brakes have some similar parts, they do differ quite a bit. Drum brake parts. The drum brake system consists of the master cylinder, wheel cylinders, primary and secondary brake shoes, multiple springs, retainers, and adjustment mechanisms. When it comes to how long these parts last, a lot of variables come into play. Typically, the brake drum housing, the drum itself, is designed to last between 150,000 and 200,000 miles. Brake shoes have a lower lifespan depending on use, usually anywhere between 35,000 to 60,000 miles. Disc brake parts. Major parts of a disc brake system include the master cylinder, caliper, rotor, and pads. How long do disc brake pads last? The answer to this varies based on a range of factors, including how much pressure is applied during the stopping process and how often they're used. Automotive technicians usually estimate most vehicles will get between 25,000 to 65,000 miles for brake pads and 30,000 to 70,000 miles for brake rotors. The best thing to do is just pay attention to how your car feels during the braking process and get the system checked out on a regular basis to catch problems early. Signs car brake parts are wearing down. There are several indicators of problems with different parts of the braking system. It's important to get your car checked when you notice these things to ensure you get any necessary repairs done. Vibrations in the steering wheel. If you start to feel vibrations when applying the brakes, it can be a sign of uneven rotor wear. Warping on the surface of the rotors can cause this. Having to press the brake pedal down hard to stop. Different parts of the braking system can wear down and require more effort when bringing your car to a stop. If you're having to press down farther or the pedal feels spongy, it can be an indicator of wear. Loud noises. Any odd or loud noises coming from your braking system might indicate different parts are wearing down. Screeching, grinding, or squealing can be indicators of wear and tear on brake pads or shoes. Car pulling to one side. When you step on the brakes, you might notice that your car is pulling to one side. Brake pads starting to wear unevenly can cause this. Brake light. If your dashboard brake light comes on, be sure to take your car to an auto tech to get it looked at right away. Braking systems FAQs. How do car brakes work? Car brakes work by converting kinetic energy into heat energy through friction, allowing the vehicle to slow down or stop. This process is facilitated by a hydraulic system that amplifies the force applied by the driver. What is the role of brake fluid in a car's braking system? Brake fluid plays a crucial role in a car's braking system, ensuring the proper functioning of the brakes by transmitting force from the brake pedal to the brake components at the wheels. It helps with lubrication for the moving parts within the system and has a high amount of heat resistance. What are the signs of worn-out brake pads in a car? Some signs of worn-out brake pads may include squeaking, squealing, or grinding noises. You may also notice reduced brake performance or vibrations as you drive. From the Universal Technical Institute. How do air brakes work? Air brakes explained simply. Understanding air brakes, enhancing vehicle safety. When drivers are transporting tens of thousands of pounds of weight in a diesel truck, one of the most important components of that vehicle is the brakes. In big diesel trucks, buses, and tractor trailers, the braking system consists of air brakes. Since air is plentiful, but hydraulic brake fluid could get lost in a leak, big vehicles rely on air-powered brakes to keep drivers and everyone else on the road safe. Air brakes are a critical component of diesel vehicles, such as trucks and buses, and are used to enhance vehicle safety. Diesel technicians need to know how air brakes work and how to troubleshoot, service, and maintain air brake systems. How does an air brake system work? Air brakes work by using compressed air instead of hydraulic fluid to apply the service brakes and release the parking brake. There are multiple air circuits in the system, and the parking brake can also be used as the emergency brake system. Drum brakes and disc brakes, or a combination of both, can be used in air brake systems. The overall functionality and safety of the air brake system rely on proper maintenance and synchronization of its components. How truck air brakes work. Air brakes on trucks work using compressed air instead of hydraulic fluid. Air brakes can be either drum brakes or disc brakes, or a combination of both. Air is pressurized by an engine-mounted compressor. The air compressor then pumps the air into the air storage tanks, which store the compressed air until it's needed. Air pressure is used to apply the service brakes and release the parking brake. There are multiple air circuits in the system. The parking brake engages by spring force in the parking brake portion of the spring brake chamber when the air pressure in the chamber is released. This also allows the parking brake to be used as the emergency brake system. If air pressure was to drop too low, the force exerted by the spring in the chamber will be able to overcome the force exerted by the air on the diaphragm and apply the brakes on all wheels. You might think of air brakes as working similarly to a hydraulic brake circuit. As with hydraulic brakes, air pressure is applied when the driver presses the brake pedal. How drum brakes work. Here's how a drum brake operation works. The operator depresses the brake pedal, actuating the air braking system. The air from the reservoirs is supplied for the brake valves. The air from the valves is delivered to the brake chambers. The chambers move the push rod to push on the slack adjusters. The adjusters transfer push rod force into cam rotational force. The cam rotates, causing the rollers to rise and force the shoes against the drum. The shoe linings contact the drum to slow or stop the wheel. The operator releases the brake pedal. The delivered air exhausts. The brake shoe return springs force the shoes to release contact from the drum. The brake shoes return to their original positions, causing the cam to rotate back to its original position. The slack adjuster returns to its original position. The brakes are released. How disc brakes work. For disc brake operation, the process is slightly different. The operator depresses the brake pedal, actuating the air brake system. The air from the reservoir is supplied to the brake valves. The air from the valves is delivered to the brake chambers. The chamber actuates the caliper, which transfers force to the inner brake pad. The caliper slides on the guide pins as the inner brake pad contacts the brake rotor. A bridge moves with the caliper to move the outer pad against the rotor. The pads squeeze against the rotor, transferring force to stop the wheel. The operator releases the brake pedal. The returning spring forces the caliper/bridge back to its rest position. The brake pads separate from the brake disc. The brakes are released. Components of an air brake system. An air brake system in vehicles comprises several essential components working cohesively to ensure safe and efficient braking. This system includes an air compressor responsible for pressurizing air, which is stored in the reservoir tanks. These tanks store compressed air until needed for braking. The governor controls the compressor, regulating the air pressure within specified limits. When the brake pedal is depressed, the air pressure releases from the reservoir through a series of valves and hoses, reaching the brake chamber or brake calipers. The brake chambers convert the air pressure into mechanical force, activating the brake shoes or pads against the drum or rotor, consequently slowing down or stopping the vehicle. A quick release valve allows for rapid release of air pressure, facilitating swift disengagement of the brakes. The overall functionality and safety of the air brake system relies on the proper maintenance and synchronization of these parts. Air brakes in different types of vehicles. Air brakes in cars. Air brake systems, while commonly associated with larger commercial vehicles like trucks and buses, are not typically found in standard passenger cars. Instead, passenger cars predominantly utilize hydraulic brake systems. These systems operate using brake fluid to transfer force from the brake pedal to the brake pads or shoes, creating friction to slow or stop the vehicle. Air brakes in buses. When it comes to safety, the safety and functionality of buses, especially those of substantial size and weight, air brakes are extremely important. Buses, like heavy trucks, commonly utilize air brake systems due to their efficiency in managing the significant braking demands posed by these systems. Air brakes in trucks. Integral to the safe operation of trucks, air brakes play a crucial role in managing the substantial weight and stopping power required for these heavy vehicles. Trucks commonly employ air brake systems due to their ability to handle the demanding braking needs imposed by their size and load capacities. Air brakes in semi-trucks. Air brake systems serve as the backbone of safety and control in semi-trucks, providing the necessary braking force to manage their immense size and weight. Semi-trucks extensively rely on air brake systems, which are vital for ensuring the safety of operation, particularly when navigating highways while hauling heavy loads. Air brake FAQs. As discussed earlier, air brakes operate using compressed air to control and facilitate the braking process in heavy vehicles. The system comprises several key components, including an air compressor, reservoir tanks, valves, hoses, brake chambers, and brake shoes or pads. When the driver releases the brake pedal, compressed air stored in the reservoir tanks is released through valves and hoses to the brake chambers. This release of air pressure activates the brakes, causing the brake shoes or pads to engage with the drums or rotors, creating friction and slowing down the vehicle. What is the purpose of air brakes in trucks? Air brakes serve a critical purpose in heavy vehicles, such as trucks, buses, and large commercial vehicles, by providing reliable and efficient braking mechanisms tailored to handle their substantial weight and demanding braking requirements. Unlike hydraulic systems found in standard passenger cars, air brake systems used compressed air as the medium to transmit force, making them well suited for heavier vehicles. Key components. 1. These are the main parts of an air brake system. Air compressor pumps air into the system. Air tanks store compressed air. Brake chambers convert air pressure into mechanical force. Slack adjusters control brake shoe movement and maintain correct tension. S-cam drum brakes apply friction to stop the wheels. 2. How they work. Step-by-step flow. Air compressor builds pressure while the engine runs. Compressed air is stored in the tanks. Pressing the brake pedal sends air to the brake chambers. Push rod moves and activates the slack adjuster. Slack adjuster turns the S-cam. S-cam presses brake shoes against the drum, slowing the vehicle. 3. Why they matter. Built to handle the weight of heavy-duty vehicles. Fail-safe system. If air pressure drops, brakes apply automatically. Required by law in many commercial and industrial vehicles. 4. Maintenance matters. Check regularly for air leaks. Drain moisture from tanks daily. Inspect slack adjusters for proper function and wear. From Autozone.com. Camshaft versus crankshaft. What they are and what they do. In any combustion engine, there are two distinctly different but equally critical portions: the top end and the top bottom. The top end is comprised of one or two cylinder heads and their parts, and the bottom end is the engine block and its parts. In the mix, the crankshaft and the camshaft, or camshafts, are found, and the engine's 4 strokes only function if the camshaft and crankshaft are perfectly timed. Learn more about these key components, the roles of the crankshaft versus the camshaft, and signs that one of them might not be working as it should. What is a camshaft? A camshaft regulates the timing of the engine's valves, controlling when the intake and exhaust valves open and close. As the camshaft rotates, it pushes against rocker arms or lifters, opening the valves at precisely the right moments during the engine's 4-stroke cycle. Without a camshaft, your engine wouldn't have a way to make sure the timing was precise for combustion to occur. For modern engines, there are 2 common types of camshafts: single overhead camshaft, SOHC. A single overhead camshaft engine has 1 camshaft per cylinder bank, so on an inline engine there would be 1 camshaft, and 2 on a V-shaped engine there would be 2. The single camshaft controls both intake and exhaust valves, making it simpler but less efficient in precision and high-performance applications. Double overhead camshaft, DOHC. A double overhead camshaft engine has 2 camshafts per cylinder bank, 1 for intake valves and 1 for exhaust valves. This allows for more precise control over the engine's timing and improves overall performance, especially at higher speeds. On a V6 or V8 with double overhead camshaft, then you could have 4 camshafts in the top ends, where an inline engine with single overhead camshaft will only have 1. It's a major difference in design. What is a crankshaft? What do crankshafts do? The crankshaft is responsible for converting the up and down motion of the pistons into rotational motion that drives the wheels. Located at the bottom of the engine, the crankshaft connects to the pistons by connecting rods, turning the linear force generated by combustion into the torque needed to move the vehicle. Without the crankshaft, your engine's power would never make it to the wheels, and there would be no order to the engine firing either. Crankshafts are exposed to significant forces from explosive combustion, and over time, they can develop cracks, become warped, or have bearings fail. Common signs of a crankshaft problem include knocking noises from the engine, oil leaks near the crankshaft seals, and a noticeable loss of engine power. If left untreated, a damaged crankshaft can lead to catastrophic engine failure. Camshaft versus crankshaft. Understanding the differences. While they're installed in different places within the engine, the primary difference between the camshaft and crankshaft lies in their function. The camshaft controls the timing of the intake and exhaust valves, ensuring the engine breathes properly. Meanwhile, the crankshaft converts the motion of the pistons into rotational energy to power the vehicle. In terms of location, the camshaft is typically found at the top of the engine, near the valves, while the crankshaft is positioned at the bottom, connected to the pistons. While the camshaft and crankshaft have distinct roles, absolutely work together to ensure engine performs as it's meant to. The camshaft's timing dictates when the valves open and close, while the crankshaft's movement is caused by the piston's up and down motion. They're connected either by a reinforced timing belt or by a timing chain, holding them synchronized. If these two components fall out of sync, the engine's timing will be thrown off, leading to misfires, reduced efficiency, or even engine damage. Related symptoms of a bad crankshaft position sensor. Signs of a faulty camshaft or crankshaft. Seldom are the crankshaft or camshaft the focus of attention, but issues like lack of maintenance can take their toll. As well, newer designs that include variable valve timing can contribute to abnormal wear, or a broken or skipped timing belt or chain can wreak havoc on them. If the camshaft has damage or wear, it will demonstrate symptoms like rough idling, misfiring, or difficulty starting the engine. If the crankshaft is faulty or damaged, you'll experience symptoms like engine knocking, oil leaks near the crankshaft, and declining engine performance. In either case, it's a serious issue that can't be corrected without in-depth repairs. An engine teardown is necessary to discover the extent of the damage, clean any metal debris from inside it, and replace any worn, damaged, or contaminated parts. An experienced DIYer might be able to take the repair on, but it often takes several days, and sometimes a complete engine replacement is the best solution when a camshaft or crankshaft piles up. If you notice symptoms and it's beyond your scope, get your vehicle checked by a professional mechanic. Ignoring camshaft or crankshaft issues can lead to even more serious engine damage and higher repair costs. Let Autozone help you find qualified professional mechanics through our shop referral program. Frequently asked questions people also ask. What is the main function of the camshaft? The camshaft controls the timing of the intake and exhaust valves, ensuring they open and close at the correct moments. How does a crankshaft work in an engine? The crankshaft converts the up and down motion of the pistons into rotational energy to propel the vehicle. What are the signs of a bad camshaft? Signs of a bad camshaft include rough idling, engine misfires, and trouble starting the engine. Can a damaged crankshaft be repaired? Yes, a damaged crankshaft can often be repaired, but in severe cases it may need to be replaced. It's also not unheard of to require a replacement engine. What happens if the camshaft and crankshaft are not aligned? If the camshaft and crankshaft are not properly aligned, it can cause engine misfire, reduce efficiency, and potential engine damage.